Of course, a more sophisticated way to look at this is two parallel lines cut with two parallel lines. So now we have transversals. But the basic idea stays the same. You have interior angles between the two parallel lines. In this case, these are the interior angles of these lines that are going at a diagonal. And then you have exterior angles, depending on which set you're looking at. Okay, if we knew that the blue angle, if we knew that this blue angle was 125, we would know all of the angles that are right across from each other. So this is 125. This one is 125, and across from it. And we could mark this again. 125, 125, 125, and 125. All of those we'd be able to mark them because they are right across the red angle. This interior angle matches perfectly with this exterior. So we could lift this up and put it right down on top of it. Lift this and put it right here, and then all the numbers would be exactly the same. We can figure out the red angle in this case by taking 180 and subtracting our blue angle off of it. That would make the red angles 55 degrees. So we could mark those as 55. Two parallel lines cut with two parallel transversals. Makes an interesting pattern, doesn't it? Now you may see this setup on tests, quizzes, and homework assignments, where we have two parallel lines cut with two transversals that are not parallel. In this case, each line is figured separately. The interior angles of the orange and purple, the exterior of the orange and purple. Again, we could lift this right up and put it over this one, and we could figure out the values of them because there are only two numbers on it. The measure of the orange angle, the measure of the purple. This line here with the green and brown takes on its own dimensions. This has nothing to do with this side. So if your question is, does this angle match the green? It does not. When we've got perpendiculars. And then everything is a right angle, everywhere on this. Then everything matches everything. So your interior angles and your exterior angles are all 90 degrees. But that's not what we're talking about here. Also, there's something called alternate interior angles. And in that case, we would have, like this brown one and this brown angle are both in the same interior part. And they also are the same. They are alternate because they're on different sides of the transversal. Those are also equal. But once you set yourself up for the values of the green, 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 and brown, 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 then you're going to be able to look at your notes or look at your homework assignment and realize that. But our interior angles, if they're on opposite sides of the transversal, they are also congruent.